So, in this particular unit, we're going to start talking about how to collect data well, whether it's through some type of sampling or maybe we're running some kind of experiment. So, to get ourselves started, the first thing we want to talk about are some of the terms that might get thrown around a lot. So, the first thing we want to think about is what is a population? And a population would be an entire group of individuals we want information about. Now, what that might look like for us could be it could be a population of students at Cardinal Gibbons High School. Within that group, we could just say, hey, actually, our population of interest are athletes at Cardinal Gibbons High School, or we only want to talk to the juniors at Cardinal Gibbons High School. So a population of interest can change depending upon what kind of parameters we set up. If we are able to collect data from every individual in that population of interest, it's called a census. And then a sample, which is typically what we end up taking, would be a subset of individuals from some population of interest. So, for example, we might be interested. So, for example, we might be somewhat interested in maybe a certain, um, maybe we're interested in dolphins in the ocean. Well, the problem is we can't take a census of every dolphin in the ocean. So what we would do is, okay, let's see if we can't collect, information on a few dolphins from different locations, just so we get kind of a different look at what's happening and get a good, hopefully representative um, sample where we're seeing dolphins from different maybe areas of the ocean, maybe even different oceans, so we can really make a claim about dolphins as a whole, right, uh, in the world. So maybe we would collect information on different sets of dolphins in different areas. So again, we wouldn't be able to get every individual in that population, but we could collect info on a few different dolphins from a few different locations to start to get a picture of what's happening with this population of interest. So one of the things you guys might be asked to do is discuss a population of interest. So here's one where the quality control manager of this factory in Denver produces computer monitors. They'll select 10 from the 10 from the production line each hour. They have 10 different factories that produce the same monitor around the country. And he inspects each monitor for defects in construction and performance. So the fact that he's only picking from his one factory in Denver, the population of interest here, just what is he sampling from? This particular manager, he can't make claims about the other 9 factories. The only thing that he can talk about, because his sample came from the computer monitors in Denver, the only population that he can make claims about, if they keep having ones that are malfunctioning, are uh, all monitors made in Denver. So it doesn't matter if all of them, if they keep getting a lot of malfunctioning computers in Denver, well, that might not affect a factory on the other side of the country. So again, the only claims that can be made about the sample or the population is that one group out of Denver. Uh, Another example, prior to an election, a news organization surveys 1,000 voters in the city of Chicago to predict what candidate is preferred. Well, again, all they talk to are people in Chicago. So this is not a sample that could be representative of the country as a whole. The population of interest here, they could gauge, hey, where does it look like people in Chicago? And maybe even more specifically, since they only talk to registered voters, that's all they could really make claims about. Right? They couldn't say anything about, you know, students under the age of 18 that aren't registered, which could be a big chunk of people in Chicago. So the only thing that this sample could really tell us about is the population they pulled it from, which was registered voters in Chicago. So, how does sampling go bad? A couple examples of poor sampling, convenient samples. They're only going to talk to people that are easy to reach. Um, for example, if we went to the library to focus on study habits, well, that'd be a really easy group to talk to about study habits because they're probably in there studying. The problem is that group's in there studying, and we don't really get a sense for all students, right? Talking about every student of the school. Well, there's a lot of students that aren't in the library, and they might have different study habits. Something's called a volunteer response sample, which is where people choose to participate. So you hear this a lot, maybe on a radio station. They want you to call in, or you see it maybe on a cable news station. People will post stuff on Twitter, taking polls. Well, the only people that really respond to those invitations are people that have a strong opinion about that subject. So really, with volunteer response, you're pretty much either going to get the people that are really, really, really in favor of something, or the folks that are really against something. And again, the goal is we want to be representative of the entire population. So if we're only taking people that volunteer their responses, you're probably going to get only responses that are skewing in one direction or the other towards those strong feelings. So you introduce some ideas, some called bias, which we'll get into in a second. So bias, like I said, a study is going to show bias if it either underestimates or overestimates a value you want to know. So again, not that any news stations or cable news sway one way or the other, but I'm pretty sure if you did some type of volunteer response sample on CNN, you might get a completely different answer or direction that you might get on Fox News. So um, the people that are going to call in are going to be very, very strongly opinionated already, probably watching one of those stations, and now you're asking them to call in. You're probably getting even more either overestimate or underestimate, depending upon, again, the way the question goes. So how do we sample well? The trick here is random sampling. We want to use chance to determine who out of a population of interest gets included. So here's where we're kind of getting back to last unit just a little bit. If it's something based on chance, then probability does tie into this on some levels. The most appropriate way, but this is probably also the hardest, is what's called a simple random sample, where everybody in the group has the same chance of being selected. So, for example, you could put all names in a hat and select from the hat. Um, Here at Gibbons, each student, let's say that we're interested in gauging student interest about a new policy here at Cardinal Gibbons. Well, each student actually has a number. So we could, each student has an ID number. And assuming that they go in order, we could use a random number generator to come up with, you know, 10 unique numbers and survey those people, right? So we take the ID numbers, randomly generate 10, 20, 30, however many people we want to talk to. Again, I guess if we wanted to and we had a big hat, you could take maybe like a 10-gallon cowboy hat or a giant sombrero and put every student's name into that hat and pick out 10 names. If you shake it up really well, everybody's got an equal chance of being picked there. So that would be an example of a simple random sample. So ways to be random again. The most common way is to use the random integers in your calculator. One thing to be aware of, you could end up with repeats. So the trick here, sorry, is we want unique numbers. So say we go over here, right? We go to math, then we slide over to probability, and then down at number 5. You can pick numbers between, I think I had 1 and 80. But what you guys might start to see is sometimes you'll get repeats within these lists. If we do it enough, you'll see some of the same numbers repeat. And so the trick there would just be ignore any numbers that repeat and just keep running this thing until we get our however many people we're going to select from Cardinal Gibbons. Okay, so another type of random sample, what is called a stratified random sample. So this time we'll break something into groups. So we take the population, we break it into groups, and we'll call those strata. And then we'll take an SRS within each group and combine these to form whatever our sample. Then we'll take our surveys or do whatever we need to do. So for example, around school, right? Maybe instead of putting everybody's name into the hat, maybe we'd like to break it up by class. So what we could do is we would break the classes up and take freshmen, sophomores, juniors, and seniors, and we'd pick 10 out of each. Right? So we put all the sophomores' names in a hat, pick 10 names. Put all the sophomores in their own hat, pick a name. Put all the juniors in their own hat, pick 10 names. Put all the seniors in a hat, pick 10 names. Or we could again use a random number generator and randomly pick 10 freshmen, randomly pick 10 sophomores, randomly pick 10 juniors, because again, the students are all numbered. And what's really nice here is all of a sudden we can start to see, is there a difference among groups? Right? Maybe the seniors have a much different view on a certain policy in the school than the freshmen. Well, if we didn't stratify, if we just took a random sample of 40 people from around the school, we might be able to see that. But now all of a sudden, when we start to really break it up into groups, we can really start to see what are these differences with respect to what we're measuring in the groups themselves within the overall population. And we can start to see trends that way as well. A cluster sample will again break things into groups, um, but we're going to break them up not by some characteristic outside of really location. And we'll call those clusters. And we're going to do an SRS of clusters. The big thing here is everyone in the selected cluster is included. What does that look like around school? Well, what we might do there is we'll randomly pick, you know, 4 classrooms. So you could, again, pick, uh, excuse me, we'll pick 4 random rooms. Well, how do we get our random rooms? We could put all the room numbers in a hat, pick them out. Again, the room numbers, from 101 up to maybe 126, and then 201 to 226. I guess we could give each room its own new number from 1 to 60, however many rooms there are. And then once we pick those rooms, we would survey or measure, depending upon what we're doing, every student in that room. So it's a little bit different. Instead of breaking things up and then taking samples, we'll pick 4 random groups. So probably the easiest way to think about that around school is let's just pick 4 rooms, go in, and then we'll get about 20 to 30 people in every one of those rooms and survey them. So again, it's got to be everyone in that room. All right, so our goal here is what do we do with it once we've collected data? And the purpose of this sample is to give us information about a larger population. So if you think about, again, convenience or voluntary response samples, they might be misleading. One, you probably get strong opinions that aren't representative, that don't fully or accurately present everyone in the population. And you're certain, whatever that population of interest. I'm going to keep using that term. Convenience, well, they're just going after whoever's easiest or convenient to reach. This is probably like when you have a hard time on a test, you probably go talk to your friends about it, and you're probably similar in that maybe you stayed up all night talking to them or playing games with them or going somewhere with them and you didn't study. Well, of course, those folks are also going to maybe feel like they struggled on the test, but that's just a convenient sample. You just talk to whoever was easiest to talk to, and of course, they agree with you. So again, does that really reflect the population of interest of everyone that took that test in a class? Probably not. A couple things that can go wrong. You can end up with what's called undercoverage, and that's when some members of the population cannot be chosen. Um, a classic example here would be using a phone book to call people, to call with a survey. Well, the problem here is more and more people just aren't using phone common landline phones, so they don't put their number in a phone book. It's all cell phones. So if we're using that phone book, it's not a matter of people not being able to choose whether or not they want to give their responses. They literally cannot be chosen because they don't have that phone. Non-response is a little bit different because that's when somebody can basically refuse to participate. If you ever seen surveys that come in the mail, or my big example here is if you're walking through the mall or somewhere with your family, maybe up towards North Hills and somebody approaches you about taking a quick survey about something, a lot of times you do one of two things. One, you ignore them, or two, you pretend like you don't speak English so that you don't have to talk to them. And that's a very aggressive way to show some non-response because right there you are refusing to participate in that study. The big issue there uh, with a lot of data collection that's out there is non-response rates are often over 90%. And that's a big issue because again, are you getting a good representative, if 90% of a population or 90% of the sample that you're trying to reach isn't coming back, you kind of start to bleed over into this idea of, well, who is responding? And it might be back to something kind of similar to what we talked about, which is that voluntary response, which probably the people that are really excited about whatever it is you're surveying are the most likely to respond. Other issues, some called response bias. Maybe it's just a bad question with a bunch of double negatives. Maybe the way the question is worded or how it is phrased could be a possible issue. Or people just don't understand the question and give inaccurate answers. And that leads to kind of a general idea or general concept called response bias, which means really people's responses are essentially influenced by either bad questions, a bad wording of a question, uh, really just a poorly designed study or survey in and of itself could lead to just bad answers because people don't really understand or maybe don't want to give an example or a response. I think this one in our most recent election was kind of an issue because a lot of people, I think, with exit polls, they said one thing. The exit polls, they said they voted for one person, but when all the votes were counted, um, maybe people were afraid to say, hey, I voted for this person. So everybody, again, all the data pointed toward one person being elected. And then all of a sudden, when the votes were actually counted, it turns out that a lot of people basically gave inaccurate answers. They knew what the question was. Maybe they just didn't want to actually say who it was. So there's a pretty significant example right there where, again, all the big news outlets were pretty confident that we were going to have a different president based on exit poll data. But again, I think that's a great example of inaccurate answers. People really just straight up lied and said, yeah, I voted for somebody else. And then here we are today.